We go, and we should be live. Hi, everybody.
Hello.
Hey, I'm joined today with Kent. Is we finally met this year, by the way, so it's been
Yeah, that
quite
was
nice.
great.
It's in London. I had a lot of fun. So it's going to do some few tweets, and yay! It seems that we are live and everything is working correctly at this point. So I'm very happy. Hey. Let me do a little bit of a tweet. For if you folks, if you have been living under a rock, you don't know Kent. But if you don't know Kent and you've been living under a rock, Kent, can you introduce yourself for a little bit?
Yeah, sure. So I am a software engineer. I live in Utah. I am a full-time teacher, and currently I'm working on epicweb.dev, where I'm going to teach everything that I know about web development. And I'll probably teach a little bit about what we're going to do today, figuring out or debugging memory leaks. This one's particularly challenging because it's hard to reproduce, and I'm not sure exactly what triggers it. And I think in our brief discussion, we both figured out where or what is causing the problem. I'm just not sure exactly what triggers the problem. So anyway, lots to talk about today. It's going to be fun.
Oh yeah, no, we are going to have a lot of fun. I see some people are joining, so this thing is working. Okay. Hi, folks. It's a few people that just joined and new followers and whatever. Welcome. So, yay! It's still a bit of early. We've still a little bit of 10 minutes or something. It's people takes some time for people to tune in. So, seems super great. Yay! Okay, like retweets and then stuff. And so I'm just doing promotion. It's always takes always a little bit. It's time. So yeah, I'm also going to do a toot. Okay, you can do toots if you want to.
Tools. What do
You're
you
not
mean?
on a toot. You're not on Mastodon. I created a Mastodon profile. So
Oh, toot. Gotcha.
a toot, yay.
Yeah,
Uh, uh,
I was on Mastodon before it was cool, and discovered that it's not cool before everybody else did.
oh, really? It's not cool. Okay.
I don't know.
In
Some people like it there. When I was there, it was a long time ago, so maybe it's cooler now. But I just didn't believe that Twitter was going anywhere, so I didn't take any time to
oh,
migrate or
look,
anything.
I created a Sampa profile because for so I wanted to interact with certain people, and certain people is they're not on Twitter anymore. So if I
Hmm.
wanted to interact with them, I literally had to be there. So that's more or less the gist. So
Hmm.
I don't know. It's look. It's what it is. I've seen there's a
Yeah.
lot more. I let me um, uh, hackerspace vibe over there. If you earlier see stuff, early I don't know, no channel on no dev channel on ERC. I don't know, this kind of vibe that I have been missing a little bit. So
Hmm. Cool.
cool. Let's we can maybe just start jumping into it. It's so bad. Okay, fine. People are having fun on the chat. We also got Raphael. So if we don't know how to get things out of, if we don't know how to fix stuff, we can just ask Raphael to join in. Raphael is a friend of mine. I hired him when I was at Nearform. He is a great Node core developer, and a performance specialist. So we'll have some fun. Just in case it will probably see some very nice suggestions. People are joining up. Okay, I think we can get things started. So, would you like to introduce the problem, Kent? What are we doing today?
Yeah. So let's see. a couple months ago, I decided I was having trouble with my own personal website. And actually, I've got a blog post that I can share if you want to switch
Yeah,
to my screen share.
let me put it if you want. Just tell me, and I'll do it for you.
Yeah,
Here you
just you
go.
can show, yeah, whatever you want, just so it's got my my screen. But yeah, so I migrated from a Postgres cluster to distributed SQLite with LiteFS on Fly. Fly is amazing, and yeah, this is a 22-minute read explaining why I did that and how I did that. And I'll put a link to this in the Twitch chat so you can take a look at that. But basically, I was having issues with outages, like related to Postgres or Redis. They're just, yeah, like things would happen. Whenever you have the extra services, it's just another point of failure. And so I had a number of times where something would go wrong with those services, and I had to go and fix it, and it was super annoying. And so I decided, because I heard rumblings about SQLite being like the reason I went with Fly in the first place was for distributed application, and you need distributed data for that. And so for that reason, I went with Postgres cluster on Fly. And because I was having these issues, I decided I wanted to simplify things a little bit. My website is not a typical developer website. Like I'm doing like pretty nutso things. Like probably the most interesting thing is that you can record a podcast episode directly in the browser. So people log in, they ask a question, I give a response, and then that turns into a podcast episode that people can listen to and subscribe to and all of that. So like this is not just your regular developer blog. I also have workshops on here you can buy tickets for, like tons and tons of stuff on here. So my website is over scoped for what most people do on their website. Anyway, I just feel the need to justify why my site is so complicated. So I was having issues. I decided to migrate to SQLite. That went pretty well considering, database migrations, like completely different database. But I started running into issues at that time. I changed quite a few things all at once, and so it was difficult to pinpoint what the problem was. But every now and then, every 3 or 4 days, my CPU usage will start to spike. And then like actually also as soon as I deploy, you can see my memory usage slowly increases, which is like telltale signs of a memory leak. So I knew that there was a memory leak. And then it would hit just some sort of critical point where the CPU usage would spike. I'm not sure what it was up to. I have a computer up in my bedroom that's like saving logs, just so that because I didn't want to bother setting up a thing that'll save my logs. So it's just sitting up there saving logs to a file, and so I can look at the logs and I don't see anything out of the ordinary when this spike starts. And so yeah, I set up a heap snapshot endpoint on my app. So at any time I can take a heap snapshot, have it download from the production deploy. And I can actually show you that. It's just this thing. Yep, V8, right? Heap snapshot to a file, and then I stream that down to whoever is requesting it. Now, not just anybody can request it. You have to be the admin user, which is just me. But yeah, so that I've got a bunch of heap snapshots that I dove into, and we'll probably look at some of those today. And pretty much found out that the problem is the syntax highlighter that I'm using, which we'll probably talk about as well. The issue is I don't know like what action is taken which triggers this spike, because like as soon as it's deployed, it's already using this highlighter. So I'm not sure what triggers this. And so yeah, I'd like to talk about that. And then the last thing is the caching. I do a crazy ton of caching on my site, not only for the blog because this my CMS is GitHub, so I download GitHub MDX files, compile those with the unified ecosystem of things, and then cache the results of that. So I cache the download of the GitHub thing and cache the compiled version, and then I also cache third-party stuff like the Chats podcast, which apparently, oh no, this is local. Okay. Yeah, but I cache all of this third-party API stuff that I'm doing as well. So like just a crazy ton of caching going on this site too. And as part of this re-architecture that I deployed, I also changed the caching implementation that I had before to one that somebody built based on mine. So it's an open source version of what a packaged version of what I had built, but it is slightly different. And I did run into a couple of problems with that, which I believe I resolved. But anyway, so lots of moving things that happened, which could have triggered this problem. But that's the problem that we're going to be looking at today.
Cool. Amazing. Thank you, Kent, for the explanation. So actually, I'm going to put back your diagram. So, okay, let's do a little bit of theory on why there is this massive crash, this massive spike of crash. Okay, so what you're seeing here is actually normal. So or normal for a memory leak. Okay, so the problem, how does the collection work? There are two kind of garbage collection algorithms. Okay, and that happens in V8, in Node.js and V8, and other runtimes works differently. So this is specific for V8. And one is the scavenge, and the other one is the mark and sweep. You probably have heard about these two before. The scavenge is very fast.
Again?
Scavenge.
Scavenge. No, I have not heard of that.
No. Okay. Yeah. Okay. Let's. So basically, you have scavenge and mark and sweep. Okay. And scavenge is very fast. I probably have a few. I did a few dying. Let me see if they are open. Those are open. Well, anyway, basically, scavenge creates put all the objects in a binary of space in memory, in a memory space. It just fill it up with objects, and when the object that area is full, it's essentially copies that checks what objects are still alive and that need to be collected, and if not, it moves them into something called old space. Old space, they're there forever, more or less. And it's this is the kind of space that it's harder to collect, because in order to detect which objects are not referenced anymore, you need to basically check one by one. Okay, so it does two phases. One is mark, and the other one is sweep. One is mark, says, "Oh, this is you are being referenced. You are not being referenced," and then sweep, clean it up. Okay. The point is, this second activity is actually very CPU intensive. So, and that's why you see these massive spikes on CPU. Okay, it's because basically it's kind of full. The memory is kind of full, and then because it's full, the garbage the old space garbage collector spends a lot of time and energy to clean things up, and after some point, it just says, just throw the towel, and says, no, I can't do anything anymore, and it crashes. Okay.
Okay, so the chart that I have, I should mention, there's like at the last bit, there's a giant spike before it drops.
Yeah.
And that is because I woke up and saw this and triggered a heap snapshot, which I know it doesn't have enough memory, so it'll crash. So I can get it to stop, because during the entire time while this is happening, my site is very unresponsive. Sometimes even static files won't get served and stuff. So I do that. But so what you're telling me is that when we see the CPU increase, it's because V8 is saying, oh, we've got to do some garbage collection on that old space stuff.
Well, it reaches a point that the memory is kind of full, or it thinks that it thinks it need to clean it up, and then it can't, and then you're basically it starts spinning, okay, and it start doing a lot of work, and then it's because it cannot clean anything. At some point, it needs to do all this work, okay, and
Right, and that's because I've got something that's hanging on to everything in memory, basically.
pretty
So
much,
every
yes,
request
yes.
that comes in, we're just creating more objects that never get removed.
Yeah, something like that, yes. And those objects are not being collected for whatever reason, and I don't know
Okay,
what.
and so what that basically that means that the logs that I've been collecting are useless because we don't really like there's no single request in the logs that is going to be like this is the one when things go out of control. It's just like it's non-deterministic.
Well, it is and it isn't, okay? You have a memory leak somewhere, and because you have this memory leak, you definitely have some routes or some actions that causes the leak, okay? Tiny bit by tiny bit. The point is, in order to trigger it, you probably need 100,000 requests or something to appreciate.
Yeah, I guess I should mention that my site gets somewhere around 250 to 500,000 visitors a month. So it is not small.
Yeah, no, that's where you start having those kind of problems. So, going into the heap snapshot, okay. Kent share me is heap snapshots, and I can probably show them to you, or if you want, I can drive you, Kent, if you prefer, if you have them handy. So if you prefer,
you go ahead and drive. If I decided I'd rather drive, then I'll let you know.
Yeah, please. Okay, perfect. Let me do. I need just a second. I need to set it up. Chrome inspect. Open dedicated tool for Node. Okay, and then I need to Chrome Windows, and hopefully it's DevTools Node.js. Okay, cool, and it's in front of Ping. We are using a new service called Ping.gg, built by Theo for this. So hopefully it works. And this is also one way to test these new screen share features of that one. Anyway, this is this. By the way, this is local in my screen. So I need. So this is where it is. Can't. Well, probably I need the date. Just a second. Date. And this is, no, not this one. It's on downloads. Okay. KCD snapshot. Okay. So I did some little bit of exploration yesterday night. So I am going to open a few of those up and then see what they look like. So you collect those snapshots, those heap snapshots. Okay. They are kind of fun. There is something, to some extent, something better that I will show you what it looks like and how to get having some more details on the stuff, okay, that you can add to your website. So, cool. So first of all, this is the first one. I need to go load some more. So this is 5422, 5420. Then
Is there a chance you could bump up the size there? It's just a little small.
Oh, yeah.
Thank you.
Sure. Thank you. Amazing. Yeah, I'll try. Okay. Yeah. Can you move your camera somewhere not behind your screen? Let me try to do something different here. Okay. Let me do that. Sorry, it's the first time we use this tool and I need to bump it. Just a second.
If you want to just hide it, you can hit the icon.
Yeah,
you want to put
okay.
it there. Yeah, that makes sense.
They wanted me to do that, and I just need to, just a second, and I need this window to be like this. Hopefully you will still see the stuff that I'm going to do. Okay, so let's do this. Okay, can you still see it, more or less?
Yeah. Mm-hmm.
Okay. So anyway, this is the gist, and okay, here we go. So what we have here is okay. So something that I would do in these cases, it's so this is the summary. Okay, this does tell us something, but before that, I tend to take a look at the statistics. Okay, in statistics, you see what type of objects you have. Okay, and here is telling us that we have some code, 30 megs, not much, 60 megs of strings,
So the
24
code, that's the string that represents the module contents, right?
the string. So code is the actual functions. So code is actually
Oh,
code. So that it's the functions once they are compiled and handled by V8 and
got it. So
Node.js.
then the strings could include the string for the code.
Yes, absolutely. If they are
Yeah, because
retained, yes,
I
absolutely.
saw a lot of that when I was diving through this.
Absolutely. Makes total sense. Okay. Then we have the some JS arrays. Okay. But what, seems very interesting is the fact that there are 277 megabytes of typed arrays. I don't know if you saw this before. Okay.
I did. Yeah, I didn't know what it meant though.
Okay. Yeah. So, and look at this. Looking at these numbers, it's still very, very high, and this is it's very, very high. It's a lot of data. Okay, sitting in there. This is very, I don't know. It gives me a little bit of. This is something that I would dig into. Okay, it might be or not be the actual problem that we have right now, but this is something that I would totally yeah, it says heads a bit smaller. Just a second. It says make your head a little bit smaller. Okay, here we go. Okay, and here it is. It's taking a lot of time for me to figure this thing out. Okay, I need definitely Theo, I need to probably, there's a lot of guides on the Ping website, so I will, next time I'm doing something like this, I will probably spend a little bit more time to get it. Oh, sorry, not this one, not what I wanted to do. And I'm moving the chat, so here we go. Okay. What is normal about typed arrays? Very low. Like normal about typed arrays, I don't know, but very low. Okay, so here we go. So it normally is very, very low, not high, low. You're not, I don't know. I can probably try to get something else, but this is like typed arrays are typically buffers, those kind of stuff. Okay, you have a lot of buffers here. Okay, so we are looking at memory leaks. Yes. So and you can see here those trees. Then we can also load these other ones. So by the way, I don't really understand the exact format. So these are is the time, right, Kent?
Yeah.
It's 5:16. Okay, yeah. So here,
UTC.
yes, UTC. Okay, perfect. So this is being taken very shortly thereafter. These two are connected next to each other, essentially, if I understand correctly.
Yeah.
Okay. So anyway, let's take a look at this.
What was happening that day? I think I took a one before restarting it and then one after restarting it, maybe, just so we could get a good comparison.
These are before probably, because it's bumping
really
from this is bumping from 379 megabytes to almost 600 megabytes. Okay, there's a question from the chat. It's we are why are we looking into leaks? I mean, you guys encounter any errors? How do you know there's a memory leak? The process is crashing because of out of memory. So yes,
you can rewind. We talk about it at the
rewind.
start.
We talked about it at the start. Yeah, it's essentially, yeah, that's what we are looking into. So okay. So anyway, what you could do, for example, in this case, okay, is I don't know if you ever done the comparison. You can pick your the other one that is close by, and it shows you what are the difference and what has been added to in between those two things. So this is probably restarting it. I don't know. These other ones, it's comparison, and this is, let's compare this with this one. I just making some random bits, okay? And you can see that there is a size delta and a delta, which is the amount of objects, okay, that are being created in the diff, okay? And this is typically, take the delta, the number of objects. So delta means how many things are being created or deleted in the given interval. If you see something like these that keeps growing, it's, you know, it does not look good to some extent, okay, when you see stuff growing here, because it means that stuff has been, we keep retaining things, okay, we keep adding objects to the heap. So when you want, this is the way I look at it. I see this delta, and I see this is not, does not look what I would like to do. Okay.
Yeah.
So something that I found though is you can look at the containment. So maybe on this one, and you can look at containment, and you can see that maybe which one it was. Sorry, just finding exactly. There is, yeah, it's global handles. Okay, just source text module. This is, yeah, compile MDX. And look, so just to clarify, something that you can do is switch to this containment tab, and this containment tab shows what are the roots of the objects and what's keeping things alive. Okay. And you can see that this is like, here we have 40% of this of the size being sorry, this is very small, it's 0%, but it's 1% of the full cache. Okay. Where is it? I am containment. Here we go. It's, sorry, I had found something very interesting yesterday, and okay, so sorry, going back to the question that we're starting at the beginning. In the statistic, we have found that we had a lot of typed arrays and a lot of buffers. So I started looking in why that was the case, because this seems way out of line. Okay, why you're allocating all those buffers? Is your application just doing moving binary data, Kent? Like, it doesn't look like it's just moving binary data all the time. You literally have megabytes and megabytes of that stuff. So I ended up going in and looking at this at the summary, and in the summary it says that you have a lot of objects. Okay. And 61% of the retained size of your system is just array buffers, which are a kind of typed array. What is an array buffer is just binary data that we have that we have in here. And look at where these wire data come from, because this is, I just wanted to this is, like, as I said, wild. Okay, it's totally wild stuff. Okay, So I had done, I opened up one of these arrays, okay? Look, these arrays, it's like 57% of all the memory of your machine is being allocated by this array. Like,
yeah, that's nuts.
it is.
That's nuts.
It's nuts, right? It's like, it's all there, okay? And it says it's a baking store, and you see the retainer for this stuff down there.
Well, what is a baking store or a banking store?
Oh, so basically you have the array buffer is the JavaScript object, okay, and then this is the actual data that you put in there. It's the actual binary data that's underneath. Okay, so an array buffer is essentially a blob of binary data. It's as a block of a chunk of memory, but it's an object in our JavaScript heap. Okay, it's an object, and the baking store is actually what contains the actual data itself. Now, where does this come from? This comes from a thing called heap F32, and it's loaded by WASM, and it come from this thing which is VS Code Oniguruma, okay, which I absolutely didn't know what it was before looking at this.
So really quick, is this a single array buffer, or is this just a bunch of array buffers?
No, this is just a single array buffer.
Whoa.
It's just a single. This is just a single array buffer.
And if I'm reading that right, it's 260 megabytes?
Megabytes, yes.
Wow.
It's that
Okay.
that's the, you know, that's your like. I was taking a look yesterday while I was preparing for this. This is like, okay, this is a good point to start. Okay,
Yeah,
like
yeah.
This is something that I would be that I think this is going to be a little bit problematic, okay, to look into. Okay, so let's okay, now I have a question, and I'm going to do a little bit. I'm just to change the screen share of this window. Okay, I'm just doing going to Oniguruma, just a second, and I am okay, just switching this and new tab. Okay, so I am just going to go VS Code Oniguruma, and in here I am going to look at that name, right? Is heap F32. Okay, so heap F32, but nothing comes up.
Right.
Okay, so but did I make it wrong or not? Okay, this is like a wild goose chase at this point. Yeah. Okay, so I had a lot of fun looking at this. I don't know. Some people have fun doing this stuff. Other people have fun doing other work. I don't know. So okay, so this is a problem, right? So let's go in, and now I need my okay. So here, and I need this open up. Just a second, and here we go. Okay, so we have here we have a terminal. And then I did a fantastic, I used the oldest tool in the world, grep -r, heap F32. That was the oldest trick I could find. Okay. And look, nobody can understand this, but this is in the bundle of VS Code Oniguruma to confirm that this is kind of the problem. Okay, I just wanted to confirm the problem. Okay.
Yeah.
Now, why is this happening? And And what is VS Code on Origuma? Oh, sorry, CD VS Code. No, it's not here. Okay, I need to switch back to the window. No, Niroguma is not broken, by the way. It's not broken. It's a little bit more.
Oh, I'm using it wrong?
No, I don't know if you or Shiki is doing something, or VS Code, TextMate, or somebody's doing it wrong. Like there is totally somebody using it wrong. Okay, I'm just I just don't know who. So I'm just let's look at it. Okay, how does this work? Okay, because I took a look. There's no documents, no documentation whatsoever. So nice. If you build something cool, folks, please make some docs, because otherwise it's impossible to understand what is going on. Okay. So anyway, let's look at the docs, which is the TypeScript definition, and it has. So this is actually very interesting. So when you create, you have two concepts that you can create here: Onyx string and a non-Onyx scanner. Okay, those are the two bits that are being used everywhere, and you can find them because I actually came to these bits also from some other repository that you share with me, Kent, where you're loading the VS Code on Iguruma, and you are creating these two functions. Okay, you're using these two functions somewhere. Now, they have a dispose method. Okay, which come from, and this is, I'm going in src index.ts, and let's look at those. This is implemented, and they have Onyx string, which is a constructor, blah, 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 and it has a dispose. And these get me very, I had a lot of my fur on my spine got a little bit all up when I saw this and started shaking very badly. Okay, can you zoom the code? Yes, I can zoom the code. I can totally zoom all the code as much as I can. Okay, so there was this dispose function, and I know for certain that Raphael that is connected here will totally have some fun, because this Onyx binding is the WASM code. What does this O3 does? But more importantly, does this omalloc do? And let's take a look. In the CC file, they actually do a malloc and a free. So if you allocate a non-Onyx string and you don't call dispose correctly when you're done with it, it will keep allocating your stuff forever. You'll never release it will never release the associated memory inside the code. Okay. Now I don't know exactly how this will end, but so basically it's when it allocates some stuff, it's and my guess it's not getting deleted. Okay.
Yeah, that would make sense.
Okay.
My guess is that's Shiki that is at fault then, because I don't do anything with VS Code on Iguruma.
Yes, this is yeah. The syntax
Did you
has
know you and I use the same new tab page, or at least I used to use that new tab page.
Amazing. Yeah, no, I love it.
Great.
It gives me a little bit of an inspiration every single time I open things up. And so I am going to in here Shiki. So it's Shiki npm. Oh, it's here, Shiki. Okay, so what does Shiki do with this stuff? Let's take a look. By the way, thank you, Arta, for maintaining this. I will probably invite you next time to debug this problem. Okay, I don't know if you're joining or not, but it's going to be, as I said, it's going to be wild. Okay, it's so here, what does Shiki do? Well, it's a lot of stuff happening here. Okay, but what we can do is create Onyx scanner, for example. Okay, and these are where these are used, and create onic scanner and create onic string. When you are doing those two things, you need to remember to call dispose after you have finished using them. And those are here, and then they are used in, so this here and here. So no. So you may ask who is using them actually. Well, there is this nice VS Code TextMate. Okay, this is fun. Okay, like literally a lot of fun. And
well, those
VS
are
Code
just type imports.
it's not the style. Yes, but they are used somewhere else. Okay, so there is in this highlighter. It's okay. So in here in the registry, create an export a class registry from the TextMate registry that come from VS Code TextMate.
Got it.
Okay. And it creates this. Okay. But if you look at in the highlighter, which is the function that you call to get the get highlighter function.
I'm calling get highlighter.
You're calling get highlighter. You see that it's creating this new registry. Okay. But when you see this get highlighter in this thing does not, there's no dispose. Like, let's look at these what VS Code TextMate is doing in the registry. Okay, and you see that there is the dispose. Okay, you need, once you're done with it, you need to dispose, clean up all this memory.
Yeah.
Okay. I don't know if it's the only problem. This is definitely a problem. Okay, in Shiki. So whenever you create an highlighter, it allocates some memory in WASM that it's is going to stay there forever, essentially.
Okay.
Now,
so the solution would be for Shiki to expose a way for me to call dispose when I'm done.
I would say that you need a dispose here. Like we will need to get some dispose added in this block to get to get to the point of not having, like, but I don't know if this is the problem, to be honest. Okay, this was very curious. Okay, it's a very, very curious thing to analyze. Okay, because I was digging and says, what is this all about? And then this is not calling dispose. Okay, so it's not calling that free stuff that we talked about. And I suspect that there are other dispose calls that needs to be called. Okay, now this is normally not such a big of a problem, because normally you use Shiki when you're building your static website, and if it leaks a little bit of memory, maybe it's not a problem. Okay. But it might well be that, like, if I understand correctly, and you might want to cycle back on what how this syntax highlighter is being used. You are regenerating your markdown content on the fly,
runtime.
if I understand. At runtime.
Yeah, mine's not a static website.
You are regenerating it at runtime. Are you so? Yeah. And this is where I got lost a little bit in your code. So when are you calling this get highlighter, Kent?
Yeah, so I call it in my markdown parser.
Let me get you back in
yeah, you can share my screen.
I can share your screen.
Yeah, here we go.
Okay, just a second.
Yeah, so this is my
Can you zoom in a little bit?
Parser. Yeah. How do we get rid of this stuff? Okay. So this is my markdown thing. I forked it from Ryan, who copied lots of it from G Goodman. So it's not public because I don't want to maintain it. But anyway, the where I'm calling get highlighter is inside of this transformer. This transformer is a plugin for the unified ecosystem. So this is a rehype plugin. And actually, I can show you this. Where that's happening is in compile MDX. I'm sure you
Yeah, this is
saw
where I
this.
got lost in when I was looking at the code when I was
Yeah.
drawing this.
So this is the remark code block Shiki, which is being used as part of the rehype plugins, which is used ultimately as part of this bundle MDX that's coming from MDX Bundler that uses MDX JS, and we get into all the unified stuff from there. But yeah, it's just one of the
for all the
plugins
people that
used
are
here.
watching that are not familiar with Unify, can you drop a link in the chat so that they can just
Yeah.
or what is Unify and just Unified? Sorry, yeah, it's
see if I can
is the
find.
Markdown toolchain, right? It's okay.
Yeah, it's pretty intense. It's extremely powerful.
Yeah, amazing.
So
Okay.
anyway, so that's where the code flows. Is once we're compiling an MDX file, this is one of the plugins. So the Markdown gets converted into HTML, and then the HTML gets transformed here to add syntax highlighting to any of the pre-elements. So I go through the syntax tree of the HTML document. I visit all elements and only process the pre-elements, that's the code blocks, and then determine some metadata about that, which language it is, all of that, and then ultimately, right here, I take my highlighter, call code to themed tokens, and then build out the syntax spans and whatever else need to be done.
Now, what seems very odd to me, so there are two things that are making it very, very hard in all of this flow. The highlighter is cached. Is this correct? Like if you go back into your MD file, that highlighter is cached.
Yes.
Does can this file reload at any point in your app?
Not in production, no. Yeah, we shouldn't be making more than one instance of this because this is what it gets exported down here. And so, yeah, there should only be one instance of this function, and the highlighter
so the
is
highlighter
declared
is there, and it's probably something else that's missing at this post call, if I understand correctly. Then, because if the highlighter is created once, then essentially you don't need to call this pose on it because you're never removing it. Question is, what else? It's good. And I know it's good news and bad news. Okay.
It's probably not my fault. That's the good news.
The good news is probably not your fault. Okay. The bad news is the design of Shiki. It's tricky business. Okay.
Mm-hmm.
I have one question. So it's so in your can you put so you're in your MD, do you call the load languages at all here?
I'm sorry, I just realized I can oh, I have too many D's. There we go. D in the wrong place there. There we go. I just realized I can send this to people and they can actually look at the compiled code, which looks basically the same as the built code or as the
Amazing.
Code I wrote. So I'll just stick that in the chat if anybody wants to look at that. So yeah, your question was, sorry, what?
So in the highlighter, like something that's so okay. So in this, let's scroll in this code, okay? You you created this highlighter and then you put stuff in a cache.
So I do cache. So once this is finished, this compile MDX, I have no, it's not going to be in here. If we look in the blog stuff here, no. Oh, you know what? It's in the MD or markdowns. Yeah, can't remember. Oops. Compile MDX. Here we go. So I have this compile MDX cached, which what this does is it wraps the compile MDX function in a cachified call so that I can cache the result of the compiled page into the cache, which is SQLite. And so, yeah, whatever is returned by this get fresh value is what gets cached.
Like my generic, like at this point, my bet would be that somewhere in this logic, we are not calling a dispose on one of the Honoriguma tokens, okay, on one of the Honoriguma strings, okay, and it's going to be a hell of hard in understanding what's what's the problem.
Yeah, so there's no tool to like see an object and then find all references to that object.
The problem is not the object. The problem is on the is looking at the inside that was a memory block. Okay, like the I don't know if people in the room, do you know how, if it's possible to how to diagnose and inspect what is in the I've never done this. Okay, I don't know how to. Basically, you need to take that blob of memory and look at what's in there, essentially. So the leak is not on our end, okay? It's probably happens inside WASM, and that's what I hope you're. Basically, it's a C leak. We are not calling dispose, and from JavaScript, that object goes away, okay? And you're not calling dispose with it. There is a trick that so there are a couple of tricks that that we could try to get this so okay, the first question would be, you're probably more familiar to the object structure. Can you get a console log dump of the object structure that you cache?
I can actually I can pull it up. 1 second.
If you can, that would be.
I have a cache admin interface on my production app, so we can look at that.
That would be amazing.
Let's see. Here's I gotta find one that has code in it. I can't ever think of it when I'm looking for it. Maybe this one has something. Yeah, so here's what gets cached for what we were just looking at. So blog collocation compiled.
Yeah.
Value, here's metadata for when it is cached, when it should be dumped. And then our value is code and read time, front matter, and slug and edit link. It really, there's nothing in here.
So you're doing, but this is a JSON representation of it, right?
Well, the cache value goes into SQLite, so it loses all references to everything.
Oh, it uses all references. Okay. So it's uses of reference before going into SQLite. Okay. No, I mean before you. So the point is there is probably some of Onoriguma token. It's
really by the time it gets to this point, like none of the code in my code base. Here, let's find.
No, I mean, is there any code from your code base that comes from Shiki as an interface or something like that?
No, there's nothing in my code base uses Shiki. The closest my code base gets to Shiki is the compile MDX here, where I put it into the rehype plugins. That's as close as I get to Shiki in my code base. Of course, this plugin is my code base. It's another package, but
yeah.
that we're looking
okay.
at.
Could you, in your local build, if you can get a production build locally, can we just try to see if we can repro a little bit? This seems about time that we start.
Yeah, we can try. So I've got the dev server build running right now, but I can do a production build and run that.
Might recommend doing production build. Okay.
Yeah.
Just because I would be way more comfortable with. I don't trust at all the dev builds. I've been stabbed by them many times.
Yeah, totally.
So maybe go on pick a page with a long with some code in it. There's no code.
Well, let's try a small page with code in it. Here, I know one. How about this one?
Yeah, that's perfect. Yeah. Try to
refresh the cache on this one.
No. So okay. If you can
when I hit this page, none of this is going through the compile MDX. This isn't going to touch Shiki or anything because that process is really slow.
So when is it going through there?
So when the cache for this blog post expires, in typical cases, or I can trigger a force refresh.
Okay. Can we disable can we make it refresh all the time? Can we put the cache to 0? Or
so I need to log in as admin first.
Yeah, okay.
Yeah, that's, since we're running in production mode, it actually is going to send me an email. So 1 second.
Fun. Amazing.
Or hopefully it will. I don't know. Maybe it. Oh, you know what? It's not going to, because this is I'm using a fresh clone of my app, and I haven't loaded all of my environment or my proper environment variables yet.
Yay.
So let me think. The easiest way to do this probably would be, I'm gonna run with everything will still be production build, but it will we're gonna run with the mocks so that it doesn't. Yeah, there we go. Okay, so now I can say log in, and here's the email that would have been sent. Whoops, I think I'm in a bad state. 1 second. Okay. There we go. Okay.
Yeah.
So now with that, I can come here, this open, and then I just add fresh as the admin, and that will bypass the cache.
Yeah, but you need to have a JWT token or something to do that?
You need to have a cookie. Yeah.
And you need to have a cookie. With a cookie. Is that your admin system is just with a cookie?
Yeah. Well, my
Okay.
user authentication system is with a cookie. Yeah.
Yeah, it's based on cookies. Okay, perfect. Something that you can. So what we need to do now is we need to set up a load testing to eat this with the cookie.
Got it. Okay.
Okay. So you go in there and you look at the request that's being done. Okay, and you copy the cookie. Yep. And then you use whatever load testing system you have installed.
Yeah.
If
I ain't got one of those.
okay, fun. Okay, fun. Okay, so we can use mine. Okay, but if you use WRK or Apache Bench, everything works. WK2 is probably the best. The one that I wrote is all written in Node. You need to compile anything. It's called autocannon. So you can just npm my autocannon-g. And the second one, it's
Okay.
literally a bad machine gun. Okay. And
cool.
it's just like that. Okay. So yeah. And you can specify the headers here and there. So if you go scroll a little bit on the options, there is headers. Okay. So you do autocannon -h, and then you put cookie, and then you capital H, and then you put the cookie.
In a string?
Yeah, something like that. Copy all of it. And I passed it. Hopefully.
Okay. And then specify the URL.
Wait a second. Sorry. I would put the scroll down a little bit. I would put the double ticks on outside the cookie. Before, like at the start of the block. Yeah.
Oh.
Yeah.
Like that. Double ticks? Oh, is that
no,
a thing?
sorry. That's probably no. That's fine. That's fine how you made it. Hopefully, I don't know. So
I don't know if that. I've never seen that in Bash. You mean just double quotes?
No. Sorry, that thing, but it's I don't think you need it before the big CD cookie, and hopefully this will. Okay. Yeah, something like this. Hopefully it will work, and then the URL at the top, at the bottom,
Okay.
Let's try and see if this works. Okay, copy this, paste it in the chat in the thing, and then we'll try.
No matches found. I don't know what that
is
supposed to mean.
No matches found.
Oh, is my
yeah, sorry. You need to put the double quote, the double quotes. I don't know, how do you call them? The in the URL too.
Oh, that makes sense. Yeah.
Yeah, because it is the question mark. So the question marks freaks up. It's working. Okay. And let's look at the logs. Is it stale? So it's still working. Is it correct?
Yeah, that all looked fine. Yeah, every one of these is going bypassing the cache for pretty much for a number of things on that page, actually.
Perfect.
But one
okay, this is great. Okay. So now what we want here, so this is unfortunately not very useful right now. What we want to stop at that. Now we know what this works. And is the cookie, if you restart the app, the cookie will change or will stay the same?
If I restart it, it'll stay.
Okay, so if you kill it and you start with the -- inspect, we can take a profile in there. So you probably want to modify this the start mocks thing, and you want to add some more. I don't know how to do that with TSX, to be honest. So I have no idea.
That's gonna be kind of tricky. Let me think if there's another way that I can actually. I think that I can start without the mocks now, and it should work.
Yeah, let's try
now
that.
that I've got the cookie. Here, let me just make sure. I come back over here. Yeah, sweet.
Yeah.
Okay.
Okay,
Good.
perfect. So if you just do that, then you can just do the dash inspect. Okay, and then you can open up the thing. Yay! Now, yay.
Should we take a snapshot?
Take a snapshot to begin with, run the test, and take another one afterwards.
Okay.
Okay.
What is this log for? Oh, bad
Bad
credentials.
credentials.
Yeah. Yeah, don't worry about that. That's fine. Yeah, we can safely ignore that. Okay, cool. Then run another.
Take another. Makes sense that this is massively bigger because the first run is always like that. Okay. Take another, run it another time and take another one.
I'm actually impressed that the first one is only 57 megs.
Hey.
That would be sweet. If my app could hum along.
Oh, but then we can get
megs.
there. That's the gist will be that we probably can get there. So go back and take another one.
Yeah, I'm gonna switch to standing 1 sec. Okay,
and this
interesting.
stays the same.
Yeah. Should I try again?
Try again.
Should we increase the number of requests in the test?
Probably, but we'll see. Can probably run for longer too.
Yeah.
Now increasing the number of requests probably not going to be. Yeah, you see, it's slowly. Try to do a run. If you do there, you can do dash. Go back into the autocannon. You could do dash D and put 60 seconds, 60, and then it will just put 60.
Run for longer. Okay.
Yeah, run it for longer. Yeah. These immediately the quality of your, when you start running this, the quality of your video went down. So your CPU is.
I don't know. I got one of those fancy new M1s.
Yeah, me too. But when doing this kind of stuff is always crap for like it's only with the new M1s and M2s you could actually do streaming and doing performance testing at the same time. You didn't have enough CPUs to do that before without the new machines.
I could not stream before I got the M1. It just didn't work. So what's interesting here is you'll notice that every now and then you'll see a big blob of a bunch of get responses. So what's happening, I think, is we've got that cachified implementation. As soon as one request comes in to go get the cached version, or to get a fresh version of that data, and then another request comes in, it sees that the previous one already is trying to get the fresh version, and so it just waits for the first one. So that's why we get these blocks.
It's pretty fancy. I have implemented some of very similar logic, and let's look at what this look like. It's an
my previous cached implementation did not do that, so that was a nice upgrade.
It's
when I got that.
You see, it's slowly there, man. If you just keep eating this will eat you alive. This is what is eating you. Okay, you can try like with like run it for like 5 minutes or something, and we can run it again, and like you can.
But while that's happening, could we just look at the delta between snapshot 1 and
exactly.
5?
Let's
Or
just do. No, I would look between the 1 and 2 and 5. The 1 and 5 of the first one. Okay, look at the statistic. Okay, this is
yeah,
super
there's
healthy.
basically no typed arrays in this one, and
Yeah.
then this is just going to keep getting bigger and bigger and bigger.
Yes, exactly. This is the
Yeah.
gist of the analysis. If you go to 4, and you'll probably see that growing. But click on
Yeah.
4.
Yep. Its
Not
share of the
much.
pie just keeps going up.
Not much.
Yeah.
But there is probably like
That
some
first
very
one,
yeah,
it
but
does get
something
a little bit.
it's
But like my thing is just slowly creeping hundreds of thousands of requests over a long period. But the other thing though is that most of the time mine is hitting a cache. I've got 200 blog posts, and so we've already gone way beyond what my website experiences in terms of actually hitting Shiki.
Sorry, can you repeat that?
So what we've done already has gone way beyond what my website normally experiences in terms of hitting Shiki, because normally Shiki's hidden behind a cache.
Yeah, I understand, but how much your cache expire? When does your cache expire?
I think blog posts are at like 30 days maybe. Here, let me find out. Yeah, so our default time to live, oh, it's just 1 day. Oh, I must have changed that when I thought, oh, my cache is good. So we'll just, and like it really is actually pretty fast, but it's also stale while revalidate. So no user ends up waiting. It refreshes in the
Yeah.
background. But yeah, so it does look like my time to live is a day, which makes sense. So I'll bet you if I increase this to a month, then my website would fall over much less frequently.
I would say so. This is something that you
Yeah.
can try and see if this is the case. Then, because look, it's very small. Okay, consider. Is there any chance that you're not that you're passing through this? That you're not bypassing the cache or anything like that? Are you always passing through cachified?
Yeah, I don't. So we do force a refresh on the cache of some things, but the blog post itself, the only time we force a refresh of the blog post is if I edit a post. And I've got a GitHub action that will trigger a refresh of that. So yeah, a user will never trigger a refresh of MDX content. It will only refresh on MDX content when the time to live expires.
Is this the only place when you're doing formatting, the highlighter stuff?
Yes, yeah. Everything MDX goes through this, and the only formatting happens through MDX.
Okay. Very interesting. Okay. No, it's. So first of all, this is probably leaking memory. Okay. It's probably not the only leak, but this is totally
the biggest one.
It's totally this is make your process go. Node.js is not liking this that situation of so many things coming through. Okay. It's so what's in the chat? Just a second. Let me look in what's in the
The
chat.
time interval between the memory spikes is like 2 or 3 days, maybe 4 days. Yeah. And so that like all of the blog posts are going to be on their own interval for for revalidation, because like over time they just kind of get off of each other. I'll update a blog post or whatever, and so they typically will be on their own schedule for getting updated. Also depends on how they should all, but within a 24-hour period, all 200 blog posts should be revalidated. And so over that the course of that time, we're getting at least 200 MDX compilations a day.
Yeah. Well, probably a little bit more, but yeah, this is finished. Let's take a snapshot.
So that's saying it went down.
It doesn't. Doesn't look at the statistics on this. It's up because it's also compressed and stuff. Like it's. Look at that number of types.
Okay, so it is
type
steadily going up.
It stayed the same. Very interesting stuff.
Well, it went up by 3 megs.
Yes. No, but I'm looking at those typed arrays, and the typed array stays the same in this case. Interesting.
Well, no, the typed arrays went from 136 to 139. Oh, no, I'm looking. Sorry, no, you're right. You're right. Typed arrays aren't really moving.
No, they are moving, but they're they
even went down between 4 and 5.
Yeah, they're staying the same. Very interesting. Okay. It's still. If we do that without the refresh, can you just kill the process and try kill the process? Eat it without the refresh. Let's just take a look. You need to close the debugger. Okay. And then just drop, just do AutoCAN. No, not with this. This is just with the fresh. Oh, you remove the fresh. Okay, fine.
Yeah, I removed it. Yeah. This makes me really proud of my server here. You're doing a good job serving all of these requests in under 200 milliseconds.
Yeah. No, it's doing a good job. It's doing a good job.
What is that?
Yeah, gravity failure.
Huh.
It's fine. Can you just have you connected the inspector?
Yeah. Well, I am running with inspect. Yeah.
Take a snapshot. Just so that in the meanwhile we are.
Yeah.
Taking some info. And we can just take a look at the ones.
That's interesting. When I took the snapshot, it went from the 1s to 2s and 3s of hundreds of milliseconds.
Yeah, it's blocking. So it's a blocking thing. It copies the full heap, and it does. So take another one.
AutoCannon is cool. Good job. I like this.
Thank you.
Probably should have done a little bit of this before deploying to production.
But to be honest, that's more or less what if you reach a point that you are actually implementing your load testing tool, you have done too much load testing in your lifetime. So you're very recent. There is another fancy tool called AutoCannon Compare that uses some fancy statistics, and so that you can normalize and compare 2 different benchmarks if you have 2 branches and stuff. Look at those. So we are going to do something. Really... we'll look at the end, because I am not. It might not even be our. Like the cheeky stuff is totally something. Might be a red herring to some extent. Like in the sense of there is definitely allocating a bazillion amount of data in there, full stop. but it might be that it's actually disposing all of it, or not. Like, I don't know. Like we saw it growing, so it's somewhere, but we could not reproduce it, which is very odd. It's very odd. Maybe. So you have 200 posts that refresh all at the same time.
They might, but they normally shouldn't.
Yeah, but they sort with the same process still up and running. Okay.
Yes.
And okay, can you just take another snapshot of this and then? Okay.
You want to just go ahead and start comparing now?
Yeah, please. Let's take a look. This is so.
Yeah. So the time to rate definitely comes from
Shiki. Yeah.
From Shiki.
And the fact that there are 200 megabytes of those is totally Shiki doing something very not nice with our process.
Yeah.
Okay. Okay. This is very, very interesting.
I mean, it is going up by a little bit.
Yeah. Very. It will take forever. Like something that you can try to do here is instead of here, do allocation sampling. Have you ever done allocation sampling?
No.
Well, let's do allocation sampling because it's actually a lot of fun.
Should I start while we're going?
Yeah, it's fine. So, okay, and I don't know. Stop, and let's see what's in there. Now, go up instead of heavy bottom up. You can, if you click at the selector at the top, you can actually see the chart. This shows all your allocations. It's fun, right? Now, this does not understand your it does not understand your minimize things. Okay, this is Express, by the way. So do you know now why I don't like Express? Okay,
because
and why I wrote my own frame. Yep, pretty much. And it's a massive
middleware's the worst.
Yeah, absolutely. Okay, and then there is a lot of this is React.
This is happening over time.
This is not. This is just the size of it. Okay, this is how much.
Oh, so the further right I go, the bigger these objects are?
Yeah, pretty much, yeah.
Huh. Interesting. Okay. So the really big things will be over here on the right, the individual big things.
Yeah, but then you want to look at the full blobs of it anyway. So so there is React. Go at the top right and let's see what's in there. What is that long? This is the world. See, try inferargs, async scope. Interesting. You have some async hooks going on, man?
I don't know.
Huh. Interesting. You always find something. Okay, let's keep scrolling a little bit. There are all these.
That's as far right as it goes. You want to go down?
Yeah, I just want to go down.
So this is my helmet stuff for cross-origin policy and all that.
What is this? If you scroll down, what is this replay response?
Oh, yeah. So that's a fly thing for multi-region. So since I can only do writes to my database in the primary region, if I get
Mhm.
a request coming in to do a write to a region that's not the primary, then I need to tell Fly to actually replay that request in the primary region.
Amazing. Okay. And now, something that would be interesting is to do something similar for with the cache disabled, I think. Just
Okay.
scroll left a little bit, and sorry, can you just in the so this is all big React stuff. Okay, this
Yeah.
is all that's the typical React. Yeah, look at this use MDX component.
Mm-hmm. That runs an eval on that when we were looking at the where was it? The hash. Yes. So this code is evaled at runtime. It's new function, this code.
We might have found your problem.
Well, good.
This
Okay,
is
so I'll show you that.
this is something that we are changing now. You don't want
Well,
to do.
it's
Where are you
like
doing the
it's
eval?
the way that it works. So,
Well, wait
here,
a
let's
second. Go back into the eval. Okay. So here,
yeah.
sorry, no, on where you do the eval in the code.
Yeah, so that happens inside of MDX bundler, which is one of my packages.
Yes. In here, you are
Oops,
you yeah, you probably need to open up that. Okay.
right here.
And yes. Okay. So it is your problem. You are caching the string. You need to cache these functions.
Okay. Because when we call new function, we're hanging on to
Yes.
what?
You are allocating some code, some very long piece of code into the code space, which is another area of your process. And if you can't allocate that memory, you will be in trouble. And
Okay.
all that whenever you're doing that, you're also losing speed, because what V8 needs to do is take your code, parse it, and compile it to binary code. If you can keep that code
Okay.
hot, you can
Oh, so
actually
we're
keep
making new chunks of binary code over and over and over.
pretty much, yeah.
Okay. So the solution there is relatively simple. Just cache. Oh, of course, do this differently, but
Yeah, you
and
need
we
you need you
say
need
cache, and the code is the um, key, I guess.
yeah, it's fine. Yeah.
Yeah. Okay. So
Yeah, I would do that.
oops. And then
Yep.
okay. You want to try the test again?
Yeah, absolutely. Like, this is totally a problem. Like 100%.
Hmm. But it's not the typed array problem, right?
It's not the typed array problem. The typed array problem is a hard stuff to figure it out. Okay.
Yeah.
This is
Okay.
not. This is the. This is something that showed up. Okay.
Whoop.
Yeah, it didn't work. Cache
What the?
delete is not a function.
Huh.
Why is?
Oh, I just I have another variable called cache.
Oh, you're doing a lot of caching.
Yeah. There we go.
Yeah.
Okay. Let's try that. Okay. Here we go.
Cool. Okay.
So now we pull this thing up and do allocation sampling.
Yeah. That will be totally something that can be problematic, okay? Because it's V8 is not as good as cleaning up the code cache like that you do all the time, okay? Look at this. This changed a little bit. If you go into the React pipe, the big React chunk, this render to string, if you scroll down,
where is, oh, there, yeah.
It's gone.
There it is.
Yeah, but it's it's gone.
I don't even see it. Yeah.
It's gone. Okay. You
Cool.
will probably get some latency bump on this too, by the way.
Beautiful. Thank you. Should probably update the docs for MDX Bundler to tell people to do that.
It's this is well, it depends. Like if they are just using them once, it's fine. But if you like what
you're doing
I
it at
would,
runtime.
if you're doing it at runtime, if you're doing a compile time, who cares? Okay. If you're doing it at runtime, you probably want to do that. Okay. And because this seems way there's also, if you put, like, you might not want to do all the time, also if you put some security stuff in there, try getting Eve snapshot maybe.
Yeah, I'm gonna do a baseline.
Yeah,
and we'll start.
That's definitely and you need probably an LRU and whatever to avoid exploding everything.
Sorry, what? Oh, yeah.
LRU cache.
Yeah, I'll probably just use cachefied. And I have an LRU cache with that. So yeah, that actually is really cool. That makes tons of sense.
So
I'm just glad nobody. I'm really glad nobody in chat has ridiculed me for using new function.
Oh, I use it all the time, man. Look, I am as much as an offender of new function as you are in this. So I use it all the time. So I'm not.
It exists for a reason.
Don't worry. It's the half of Fastify is based on new function, so it's.
Okay, so here, before we did anything, no typed arrays. After we do stuff, we've got typed arrays.
This is this
barely nothing now. Oh, right, because we're still it's still cached.
Yeah, we are doing but this is I've removed that block of memory allocation. Take another one of the heap snapshots. After it's still running, right?
Yeah. So it is getting steadily bigger. Something is making it increase over time.
Yeah.
I'm hitting this with far more requests than I typically get. Like maybe 10 times more requests. I do get a lot of requests per second, but yeah, not quite this many.
Yeah, but the point is we are trying to compound it in a very small amount of time. So it's fine. Like this is stable, by the way, because if we run it over time, I think this will stay.
That even went down that time.
Yeah, it's normal. It's okay. So if you stop this, I'll show you some more flags so you can keep playing with it.
Okay.
And people will be, I think will have fun in it. I have to go in about maybe 40 minutes top. I have I need to feed my kid. So if you this is the first world problems, like feeding kids. And so okay, and if you open your package.json, I am just showing you how to add some of this fancy flags. Okay, instead of inspect, You can do --trace -gc.
Okay.
Okay.
And
Now
then run that.
run your code. Now you see all those allocation failures. Okay. This is where scavenge. So okay, let's look at that. Let's look at what it's doing. Okay. So scavenge is the fast garbage. It has 2 garbage collector. So it's scavenge is the one that takes very little amount of time. So it's basically you allocate objects, and those objects are put and cleaned up very quickly. So if your objects can only live within a scavenge loop, your application never grows in memory, essentially. If it's what survives goes into mark and sweep. Okay, what goes in old space, which means it goes into, and then it cleans up by mark and sweep. Okay. And you can see, so the way you read this is you see a number, and then you see a number it goes to with an arrow. So it said that it goes from 24 megabytes to 18.9. Okay. Yeah. Does it make sense?
What's the parentheses number?
I have no idea. Okay. It's I can make a few educated guesses, but the major one is the left one. Okay. I think that number is the size of the space. Okay. That's my read. It's mostly constant. Okay. So anyway, if somebody knows, happy to do. So the mark and sweep one is the one in old space. So something you could do in production to check is enable this trace GC, so you have all this data.
Okay. And does that will that really hammer my
0? Just logs.
My logs, yeah.
This is just logs.
So every request will give me this giant block of logs.
No. Run not that many. You run the autocannon.
Okay.
This is just for the process starting. Okay, run autocannon. It does some stuff. It tells you how many times. Stop it, and then we'll look at it. Okay, so it shows how many times it's doing scavenge for each one of.
There we go.
Yeah.
Okay. So am I right in thinking this is bad?
Yes, but this is React. So
really?
The problem, it's React, yes. So it's not bad. It's how React works. Essentially, you see that big closure pile is Express and React, all these frameworks that do a lot of re-entrant calling. They allocate objects at the top, at the utmost top scope, and then you go down. Now, even if you are executing a function deep down, you cannot clean up the memory at the top of your stack. So you're running your function, but you have your stack is at the top, and then you're at the bottom. You have allocated a big object, and that object will never be cleaned up until you unwind the full stack. And also, React allocates a lot of objects. Every component is objects, right? And because of that, those needs to be collected. So it's no help with React. Now, if you go up, you will see that you mostly, though, this is good, because mostly you're very little mark and sweep.
Yeah.
So the mark and sweep is when you need to clean up the old space.
Yeah, I've only got 15 of those with all those requests.
That's where. Okay, your mark and sweep is pretty good.
So the allocation failure, what does that mean?
It means it cannot allocate any more data, so it needs to trigger the garbage collector to allocate more data.
I see.
It allocates this very fast garbage collector to do this work.
I see. So that's what you mean by this being a React problem, is that they just allocate tons and tons of objects and then just rely on what this is doing. So when it says allocation failure, it's not really a failure. This is expected behavior.
This is expected behavior, yes. At this point, yes. So you can complain about React design, okay, but it's not. It's this is some of the difference between React and some of the more new frameworks, essentially, that they rely less on these massive tree-like data structures that are created and rendered in one step.
Yeah. Okay, that makes sense.
Okay, you can see why Svelte is so much faster or stuff like that. It's also because of this kind of stuff. Okay, because it does not need to create all those objects essentially, and so they don't need to be collected.
And React just relies on garbage collection and it's
heavily.
fine.
Well, it allocates a lot of objects. So it allocates a lot of objects. It's my my main concern about React is React server-side rendering is about the fact that you have a pseudo HTML in your TSX files, and like your components are pseudo HTML, and then you convert them to objects to convert them to HTML. It does. You have already the thing at the start. Okay,
we could discuss this at length, but I think that what we've determined so far is we can't reproduce the main problem locally. Is that basically?
I would. So okay, I'm just going back. So okay, yes, at this point, yes, but those type of bits takes kind of forever. Okay, like finding these kind of problems is it's a massive pain. Okay, because you need until you cannot reproduce it locally, you will never find a way to fix it, and reproducing it locally can take literally forever. Okay,
yeah,
and it's something. Let's do something different, okay? Here, can you do the? Let's do an allocation sampling of the refresh one with refresh. So
yeah, okay.
This seems a good way of. Yeah. No, this is refresh. Have you got refresh enabled? Okay.
Yeah, fresh.
Oh, okay. Yeah.
Hold on.
Wait.
Oh,
It's not in the right. It's not in the right spot. No.
It's failing.
It's not in the right spot. Man, it's not in the right spot. The cook is not in the right spot.
Oh, yeah, you're right. You're right. That is the problem.
It's the question mark is that yeah.
Thank you.
Yeah.
Okay, so now am I on the right thing? I don't think I was on the right one. I restarted. Okay.
Yeah, okay.
And you leave that running for like 10 seconds?
Something like that, yeah. Okay, stop. Just whatever. Just want to see what's going on in here. Okay. This is the look at the top ones. Total size. These are the function. So, and it's all very good. Okay, so this is where it's a very small leak over a long amount of time. Cachified Mendiax. Your Okay, this is where it's get cache fetch. What is that exec at the top right? That exact, there is an exec called visit.
Sorry, I'm not seeing. Oh, right here. This
Yeah.
is we're compiling Markdown.
Okay, perfect. Yeah, makes sense. Executor, all of this seems all very good. This is like something that, if you like that kind of stuff, okay, something you can do is there is a module that I myself and some ex-colleagues wrote. It's called a near firm. I'm getting you the name, and it's a heap profiler. I'm pasting it in the chat here in Twitch. Okay, and you can, with this, you could trigger the heap sampling profiler from from Node itself. So you
to generate heap snapshot and stuff. I'm already doing that.
Yes, yeah, but you're not doing the second one. You could record the. You can do the. Oh, sorry. If you go into the stuff, go in the. You can do the heap sampling profile and the allocation timeline, but you're not doing that.
Okay. And what additional information would that give me that I'm not getting from the heap snapshot?
You can get it done in production.
Right. It seems to me that we still haven't figured out the typed array problem with
we have more questions than where we are asked. Than where we started. But this is typically brainstorming session to some extent. It's my guess is fixing this kind of problem is a few weeks task to understand, to nail it down, and you need to sleep on it a few bit, like take a break, sleep on it type of thing. Okay, you can. It's for example, a few things that you can try is try in increasing that cache bits for the MD for the highlighter stuff. Okay, see if increasing it to, instead of 1 week, it become 1 day, make it 2 days or 3 days if the rate of growth slows. Okay, that is something that is actually can be very helpful to see and verify. Like, again, if you put it on a week, it does it grows at all? Okay. Something else that you could try is and we can try it now probably. Okay, and it's try doing an allocation instrumentation on timeline.
Okay.
And run a benchmark, or is still running. You run a benchmark.
And this is without the cache.
Yeah. So if you look at it, what it is it's oh, you probably want the stack too. So stop this, run with the tick to record stack trace of allocation.
It's not letting me.
No. Oh, okay. Fun. Well, start it anyway. Let's see what this look like. Okay. No, but this is the sampling profile. This is not, sorry, it's not working as I would expect. So, sorry, go back. This is instrumentation on timeline. Okay, so it's the last one is the profile tree, right?
Yeah.
Okay, go at the chart at the top. The selector.
This one?
Sorry. No. Sorry, in profile tree.
Oh, gotcha.
In the selector, yeah. It's not the bits that I would expect it to go. So put heavy bottom up. Okay. So the one, what is this at? Click on it. What? Sorry, why
that
are
could
you?
Be, so this could be when we're running locally with Mox enabled. We make a request to GitHub, like to get the MDX file. But since I have Mox enabled, MSW intercepts that and routes it to the local file system where those MDX files
Yeah,
are,
but
and then
who
sends it.
is starting a? Can you do a grep on your? Let me do the grep, okay? And let me see. I have your website here. Just a second. I'm just doing a very quick grep and see who is starting async hooks for you, because you are creating these promising tools with destroy tracking, which is extremely bad for perf. Like big offender for perf. I'm just Prisma get session. How do you get the session?
From the cookie. I'm using sessions. So I have a table for sessions, and I read the cookie to get the session ID for that table, the ID in that table, and then read the table through Prisma.
Yeah, but like it looks like you're using async hooks somewhere, in the sense that you're doing some concept like thread locals or stuff like that.
Like what?
Async locals, like something where you magically get the session from calling a static function without not passing a request, something like that. Or maybe it's about the timings of the request. Like there is some one of the modules that you are using is definitely storing stuff in the in that block. I might be a remix thing. I don't know. Like I might even be a remix.
Sorry, I feel like
what async hooks do. Okay, async hooks enable you to track whatever asynchronous operation, and very often, like this get session ID. What is this get session ID do? Line 73. Get session ID.
Yeah, so that just calls this function here to get the session ID key from the session object, which is a remix session. using its session storage API. So it stores, there's overloading of terms here, but it stores a session in the cookie, and all that I store in that cookie is the ID of the session object that's in the table. And so when we say get session ID, it's the ID of what's in the table. Calling this a token is a misnomer. This should be a session ID. But yeah, then I get the user from their session ID.
Okay. I mean, let me screen share my stuff. Sorry, not the Chrome. I am trying to figure out where you're using this. Okay. So just a second. I need to, yay. Okay, here we go. And it's a massive blob of, here we go. Okay. It's a massive blob of test. So it's, I don't know who is doing it, okay? But somebody is using async hooks. And just, this is other odd stuff that I'm seeing, okay? The stuff that I would not expect, okay? This is what, sorry, this is the more, it's stuff that I would not expect it to, if somebody knows, and this is a long, let's do this, grep require async hooks.
You may need to change that to double quotes too, or try the double quotes version.
Yeah, makes sense. Look, VM2. Are you using VM2 somewhere?
I'm using unfinished. I don't know what VM2 is, but I am using unfinished.
Yeah, let's do, and I do just let me try also this. And yeah, but unfinished should not. Yeah, should not double quotes. And this is very interesting. Haha. A sync source, but this is a sync source. Okay. Oh, you have open census.
I guess so. I don't know. I don't use it directly.
This is.
I definitely use Prisma all over the place.
Yeah. But Prisma is just using a get async source. Okay. And this is also import async. Let me look at it. Like use Prisma is over the places. Yeah, I just want to understand where this come from. Very interesting.
So you're saying Prisma's usage of async hooks is fine?
I seem so. I'm just one. Okay, this is definitely a problem. Okay, open census. This is definitely a problem. Okay, who is open census core? So package lock open census. Okay, who is?
It's coming from PM2. That's just development time, though.
You're not using it in prod?
No.
Okay, great.
Okay. And with these tests as well, I'm not using it.
With?
The test that we were just running, because I was running production mode, so it's not being used.
Okay. I think I know what the problem is. Don't worry, it's me being stupid. It's me being stupid. Sorry, it's a totally. I read hook, sync hook, and yeah, this is fine. This is fine. This is fine. This is fine. Import sync. Oh, Prisma is using async hook. Fine, it's totally okay. It's me being stupid. The inspector trigger async hooks, so I totally forgot.
Okay.
It's not you. It's a Node Core integration with the inspector that needs the async hooks to exist, and therefore it shows up. But and therefore it will show up here. Okay, and it makes sense. Okay, but it was surprising to me. But what is that? Do we know what that add? So you have this add function.
Yeah, I don't know where that's coming from. It's not going to take me to it either.
No, it's because you need the tick that track down the file, the size, the file size. But it doesn't seem to be working for whatever reason.
Here, I'll restart the server maybe.
Yeah, let's try. Oh, yeah, sorry.
Here we go.
I need to swap back to Ken screen. Just a second. Okay, here we go.
Okay. Hey, this seems to be working. So now,
yeah.
If I run the test,
yeah,
doing something.
Yeah, and it tells you exactly what is being kept alive.
Oh, interesting. So things are being allocated and they're being kept alive.
Yeah, and it tells you exactly.
Some of this early stuff makes sense to stick around.
Yeah,
because
totally.
we're bootstrapping the app. But this new stuff, all of this we should get rid of that. There was something right there that exploded.
Yeah, the I think it's the gray stuff.
Okay, we just got rid of a big chunk of something.
Yeah. You're starting to get rid of stuff, and then you see.
Yeah, very interesting. So can I just not see what's right there, or did that all just get blown away?
No, you need to stop recording, and then you will. If you stop the recording, you will start seeing stuff.
Yeah, that's very interesting. So what's in the stuff that's in blue is the stuff that was never cleaned up.
That's my guess. Yeah. So this is the data, the stuff that is still alive, and you can understand exactly what was. Yeah, you see, you're navigating it correctly. So
very interesting. Okay, so
in here you can see, you can move. You can see how much memory was allocated and stuff.
Wow. Okay.
Yeah,
I'm not sure what to make of this.
Yeah, you see it. It's not. It's. As I said, it's not. How did you do that allocation timeline?
Sorry.
It's Shiki again. Yeah, of course. We're running the refresh stuff, so I'm suspecting there's a lot of Shiki. Somebody is actually asking, how did you do that allocation timeline? Maybe we can just do it again. So for the people, so you connect the inspector from on your process. You do allocation, instrumentation on timeline, and then you tick record stack trace of allocation. Then you hit start, and you run a load test on your system.
Yeah, I'm still running that.
Yeah, you can see when stuff gets collected and when stuff stays there.
I love that. That's super cool.
So you see that it gets okay. Yeah.
So there was something that got allocated.
Yeah, but that
5
was
megabytes.
Yeah, but you see the way to read this. If you go at the bottom, the problem here is not the stuff at the end; is the stuff at the beginning that stays blue.
That's stuck around. Yeah. Can I look at this and just see the stuff that stuck around? Is that what this is?
I think all of. Yeah, that's the stuff that stuck around. That's on the stack right now at that moment. Yeah, this is
And yeah,
cheeky. And you open it up and it's damn cheeky.
yeah, every time.
It's
So
uh,
if this is not mission critical for me, I
yeah.
just need to switch to a different syntax highlighter and my problems will go away.
Very likely so. Or you can do a try for like, okay, something very stupid, okay? If you can live without syntax highlighting for 2 days, you could do, or one of your replicas in your system, you run it for 2 days without syntax highlighter and see if your problem goes away. That's probably one of the options, okay? Not pretty, but you can get very quickly to the bottom of the problem, okay? But this is, look, okay, you see this, okay? So here, these objects that gets allocated, you can see that you get there is the O free, so that is some of the stuff gets freed up. Like you see, this is the it's still connected to that DAM array that's eating your app. Okay.
So the fact that we see O free in here, does that mean that somebody is actually calling dispose at some point?
Yeah, something is calling dispose, yes. But this O free is holding up on, it's calling this massive object, which is this that contains the 40% of retained of everything. Like this is the problem, okay? That's the problem, okay? And then, wait a second, there is also that's probably Graceful FSQ. It's probably your the mocks, right? Or we're not running with the mocks here. It's without the mocks.
Yeah, sorry, where did you see that?
If you go down in the second block, no, in that of free, or will you see it in here? If you go down, you see there is gracefulfs.q. Retain side 10%.
Yeah, we're not going to get anything useful in here, right?
It depends. It's not that. So options. A few options. It's do the syntax highlighting on using a worker thread, and then dispose the worker thread every now and then.
Oh, that's a good idea.
Okay. So instead of so basically you just you send the message to the worker thread, do the job there. It will not clog your process. You can just kill the worker thread if it goes over the limits, and that's it. So it's and you load this VS Code on Oniguruma and everything in its own in a protected shell, so you can kill it without. Or to some extent, after you do each rendering, you can dispose of that worker thread, essentially.
Yeah. I think that might be the thing I try. That seems like the least amount of work. And this is just my blog.
Yeah, I know, man. Look, as I said, this is that seems problematic. Okay, I have no clue how to debug. Like, it's hard. Okay. I'm
not willing to put that much work into it, so I'm willing to do the suboptimal.
You see, this is the gist of. This is where it's totally doable. It's just how much effort will it require? But something that would be very interesting to try is moving things on the worker thread. So put all the stuff in the worker thread, and then put all the stuff in the worker thread, and then we can get.
I think I'll put the entire compile MDX into the worker thread. Yeah.
So there are two good modules for this kind of work. Okay. if you want a couple of suggestions. One is called Piscina.
Sheena?
Piscina. It's Italian word for pool. I'm going to give you the URL. PISNA. No, I'm putting it. Just a second.
Okay.
Giving you the. And then there is the one that Vit uses. Just a second. I am where I've lost you. And here it is. So it is this. Okay, that's one. Yeah, that's the one.
And Tiny Pool is recommended
And
by
I think
chat.
it's Tiny Dash Pool. Yeah. No, sorry. I'll get that. Is I'm going it.
Oh, Tiny, no
Tiny.
no dash.
Yeah, it's a fork of Piscina without with less dependencies. So you might probably want, depends on exactly what you need. You might like, as I said, it has less stuff. Okay, if you don't need those things, you don't need it. And you probably want this, to be honest. And it's if you go in, I know for certain that Piscina has the API that you will need. So basically, you want to not keep the workers alive for long. And there are some options for that. So you want to put the minimum amount of threads and the maximum amount of threads. So basically, you could configure it so that you don't want to keep any threads available for it. So whenever it's done, it just kills it. So you don't need to worry about closing it up or starting it up for you. And you can specify a maximum amount of threads so that you get the boost. Okay, so that you can, given that this is a CPU intensive operation, you could actually save some time to, you can not kill your machine by spawning so many threads.
Yeah.
And,
okay. I think I'll look into this.
It's I think that would be my all things considered, that will be my best recommendation by looking at it. I don't know exactly where, if it's, where is the problem in the caching bits in the between Shiki and the caching that you do, and the VM encoder, sorry, and the VS Code, the TextMate stuff. I just don't have a clue. It's very hard. The fundamental problem is it's very hard to guess where is the problem. Okay, so it's not simple. So but eventually it manifests itself with Shiki. So I would,
that's definitely the problem.
It's well, at least that's definitely something that needs fixing. Now, if it's that the problem that we are looking at, that we are searching for, we'll see after it's fixed. But it's a likely victim. I don't know. It's a likely highly suspect. Okay, it's our main suspect. It's our main suspect at the moment. So we're playing Cluedo, and it's our suspect at the moment. So it's
cool.
Well,
and also like the caching the new function call, that is quite helpful as well.
I think you can measure. Let me know if you can get some measurement on how much time it takes. It has improved things, because I think you will be able to see the difference. Like it should be measurable by some fraction of a millisecond or something. But
I'll deploy that first.
That is a tiny fix, and will help the health of the process. But moving the stuff to the worker thread would be, and will probably solve all the problems that you are all the problems that you're facing. You just need the strings in the end, right? If I understand correctly.
Mm-hmm. Yeah.
So yeah, if you just need the
And
string,
I cache them too. So even like adding additional time through serialization of the process and everything is actually not a big deal for me.
Yeah. So yeah, that will be probably my best recommendation. Once you have done it, you're so welcome to come back, and so you can demo it, or you can do a little bit of recording. I can join your stream, and you can demo it with me. We can chat and review the implementation. I think all the people will be very interested, because this is, production system with traffic, and most of the time you don't see the source code of those live. I don't know and people can see the problem and tinker with it, and then so on. So I enjoyed the session quite a bit. Thank you, folks, for being with us today. And I think it's time we say goodbye. And we had quite a bit of a turnout, and 2 hours and stuff counting. So I'm super tired, and I need to go feed my daughter. So
Yeah.
I am.
Take care of your daughter.
Yay! Bye, Kent, and see
Thank you so much. I really,
time.
really appreciate you helping me working through this. It's been a huge help.
No, it was a lot of fun. Next time, whenever you have something very interesting, or I don't know, something very hurtful or whatever, I'm very happy to do. If somebody else has something like that, I love doing this kind of live debugging on stuff. So will be fun.
Yeah.
Bye.
All right.
Bye, Kent.
Bye. See ya.
Bye. So. Thanks, folk, for coming. Okay, I adjust myself now. So it's been fun, and let's do a little bit of ride, maybe. Where do you want to go? I think you want to go to see Prime, so I'm going to send it to Prime. So and you will have some fun. So bye, folks. Bye. It's been fun. Bye.